It's me, Dr. K. Chitralakshmi, Department of Mathematics Self. Today our topic is Algebra and Trigonometry. It is classical and to be worked out. So in this the Algebra and the Trigonometry, first we are going to see about reciprocal equations. Definition. So definition of a reciprocal equation. A polynomial equation f of x equal to 0 is said to be a reciprocal equation if the reciprocal of each root of it is also a root of it. For example, suppose when you take 8 and 1 by 8. What is 1 by 8? 1 by 8 is the reciprocal of 8. So, when you take 8 in the equation f of x equal to 0, also when you put 1 by 8 in the equation, then the two equations will remain the same. So, nothing but the reciprocal equation. So, once again I say, when take an equation f of x equal to 0, it is a type of polynomial equation. So, when it's said to be a reciprocal equation, if we change x by 1 by x, the equations will remain the same. Such an equation is called an reciprocal equation. That is, doesn't change if any equation called reciprocal equation. So, a very important note of it, when you find a number 0, what is 0? Actually a real number, but it could not be a root of a reciprocal equation. Why? Because the reciprocal of 0 is 1 by 0. What is 1 by 0? 1 by 0 is undefined. So, we cannot put in the equation that the reciprocal number 1 by 0. If you put it, then it will be undefined. So, remember 0 cannot be a root of a reciprocal equation. Note 2. So, what is note 2? So, note 2 are the remembers to be remembered. So, take f of x equal to 0 and it is a type of degree n. Concentrate what type of the degree. So, it is put of degree n and it has exactly n roots and no more. You all know what is meant by degree and what is meant by the roots previously. You have studied already. So, I mentioned only an equation will be taken and degree will be taken and the exactly n roots will be taken and no more you will be find out and understand. And hence, each the root alpha I coincide with 1 by alpha I, because previously I can say if you put x in 1 by x, those equations will remain the same. So, here also when you find an equation of degree n and it has exactly n roots, the reason alpha I coincides with 1 by alpha I for some j is equal to 1 to etc. n. So, if these things are happen, what is the condition of the polynomial equation? So, coincide with the root alpha I with 1 by alpha I, and what is the condition? So, the condition for the polynomial equation to be a reciprocal equation. Suppose if one thing that is was taken, then automatically you will be understand that what are the things that is to be remembered. So, here it requires a condition for a polynomial equation, because we are taking the polynomial equation and therefore the condition will be provided. So, what is the condition? So, the condition, because we are studying also reciprocal equation. So, for it a reciprocal equation, for it remain on a polynomial equation, what is the condition? So, take f of x. F of x is already a polynomial equation. What is the symbol of it? So, writing the polynomial equation, it of the form a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus etc. plus a n minus 1x plus a n equal to 0. So, take it an equation 1. What we are studying? A reciprocal equation. So, I have taken the equation 1. So, to be checked that it is a reciprocal equation, the roots are taken, that is alpha 1, alpha 2, etc. alpha n. So, what is the condition for it? So, the page will understand what is the condition. So, previously I take an example of it, that is x square is equal to minus 1. When you put x equal to 1 by x, that is the previously the note 2, okay, so what it understand, okay. X square minus 1 equal to 0, x equal to 1 by x is always to check whether the given equation is in a reciprocal equation, x equal to 1 by x. Yes, what is the equation? X square minus 1 equal to 0. What is that? Now remember, x equal to 1 by x will be put off in the equation, round of what I the equation x square minus 1 equal to 0, x equal to 1 by x. So x in the place when you take 1 by x square minus 1 equal to 0. So when you rearrange the equation 1 minus x square is equal to 0 and then also x square minus 1 equal to 0. What are these? These rounds are saying the same equations. That is x square minus 1 equal to 0 and x square minus 1 equal to 0. What are the roots? X square minus 1 equal to 0. When you solve an equation, what are the roots? 1 and minus 1. Okay. So 1 and minus 1. Okay, they are the roots and we are putting x equal to 1 by x. We are checking that it is a reciprocal equation of the given the equation. Okay, so x square minus 1. So it is a example of the noting. Okay. And now we are going to find the condition of it, finding the given equation f of x equal to 0. So previously we have considered f of x equal to a naught x power n plus a1 x power n minus 1 plus 8 x power n minus 2 plus etc. plus a n minus 1 x plus a n equal to 0. So this is the polynomial equation. Polynomial. Okay, so f of x is nothing but the polynomial. We are, once again I am saying that we are studying the reciprocal equation. So what is then to remember? Put y is equal to 1 by x. Okay, so or x equal to 1 by x. So here I have taken put y is equal to 1 by x in the above equation. That means x equal to 1 by y. Therefore, the equation will be totally changed. That is a naught plus a1y plus a2y square plus etc. plus a n minus 1 into y power n minus 1 plus a n y power n equal to 0. So take this as equation number 2. So previously the equation number 1, now the equation number 2. So the equation 1 is a reciprocal equation. Why it is called the reciprocal equation? Those two equations are same. Okay, the previous slide we are showing that the equation 1. Now we are presenting the two equations and after changing y is equal to 1 by x. So this will be the equation. Therefore equation 1 is a reciprocal equation. 1 and 2 are equal. Therefore a naught, a1, a2 etc. I am not inserting a1. Okay, so sorry. And a naught, a1, a2 etc. an. Then, so what is to be multiplied? Because k into an minus 1 etc. an for some non-zero real number k it will come. So this would imply a naught is equal to k into an and a1 is equal to k into an minus 1 etc. an is equal to kan. And finally a naught an is equal to k square an a naught. Therefore the condition will provide you that k square is equal to, when you equate it, the last then what do you say? What you can say? K square is equal to 1 and then in place k is equal to plus or minus 1. What we are doing? We are equating the equations and finally we are getting the conditions because we require the condition for the polynomial equation remain to be the reciprocal equation and therefore k square is equal to 1 and k is equal to plus or minus 1 is the condition. Okay, so case 1 because we get two cases, that is k is plus or minus 1. So k is equal to plus 1 will provide you one case and k is equal to minus 1 will provide you another case. So first of all we start with k is equal to 1. So k is equal to 1, what are the coefficients, what is the position of the equations? That is a naught is equal to, previously we get what is a naught is equal to k into a1, a1 is equal to k into n minus 1 etc. an is equal to k into a naught. So we are putting what is then k is equal to 1. So k is equal to 1 we are putting and what will you get? That is finally I am rounding off. That is a naught is equal to an, a1 is equal to an minus 1 etc. an is equal to a naught. So we get a reciprocal equation of, this is whatever the equation we have to mention. Okay, so if these will happens, if these will come, so what do you remind then? What is the equation? It is a still that is we call it a reciprocal equation, but it is of first class and the first type or first kind. This what we are giving. Okay, that name to itself, that part of the equation it is called reciprocal equation of first class, first type or first kind. When you are putting the case k is equal to 1. Okay, so a naught x power n plus a1 x power n minus 1 plus etc. So what are the coefficients? The coefficients are nothing but because by the side of it the x power n what are a naught and then a1 etc. These are the coefficients. Now the coefficients what the positions they are. So I am showing that a naught is equal to an, a1 is equal to an minus 1 etc. an is equal to a naught. Okay, so where they are locating, a naught here and the last n we see an. So what are the positions we are? So equidistant from the beginning and the end. We are equal because they are equal. A naught and an are equal. Therefore they are equidistant because it remains the coefficients plus saying and now from the beginning and the end the coefficients are equal. And so it is a reciprocal equation of the first class, first type and first kind. Now going to case 2, when k is equal to minus 1, a naught is equal to kan, a1 is equal to kan minus 1 etc. an is equal to ka naught. So k is equal to minus 1 when you put off in those equations, what do you get? A naught is equal to minus 1 a n and a1 is equal to minus 1 a n minus 1 etc. A n is equal to minus 1 a naught and hence what are then remain? A naught is equal to minus a n, a1 is equal to minus a n minus 1. What we are seeing now? Previously we are seeing a naught is equal to a n. Now we are seeing a naught is equal to minus a n and therefore the sign will remain. Therefore they are, but actually they are equidistant. That is from the extreme ends they are equal actually. Extreme ends they are equal actually and therefore they are equidistant from the beginning and the end they are equal, but they are put of the sign. Okay, so but opposite in sign we are put in magnitude. So therefore we are reading that the coefficients are equidistant from the beginning and the end are equal in magnitude and the opposite in sign. So this is case 2 and therefore whatever the equation, so it is read as it is in reciprocal equation of the second class, the second type or second kind. So the previously when k is equal to 1 we get an equation reciprocal of first class, first kind and first type, but we are getting when k is equal to minus 1 it is a reciprocal equation of the second class, second type and of second kind. So we are actually getting the conditions for saying the reciprocal equation, the polynomial equation to be a reciprocal equation. So another thing is to say that the type of reciprocal equation, there are 4 type. So there are 4 types of reciprocal equation. So first is first class and of first degree, even degree, first class and of odd degree, second class and of even degree, second class and of odd degree. So what is meant by first class and of even degree? First class and of even degree means they are the extreme ends and inside the intermediate the coefficients they are equidistant from the start and the end, but they will be in equal in magnitude, okay, and not of opposite sign. So but mentioning it is an important thing that mentioning what is that? It is of even degree, therefore the highest power of x is, now here it is 4. What is 4? 4 is an even number, therefore it is of even degree. Therefore it is an example of first class and of even degree. That is 6x power 4 plus 35x cube, 62x square and 35x and then plus 6. Whereas 6 the first the place and the last place. Okay, so they are equidistant. And where are 35 in x cube and then 35x. Okay, they are also equidistant. Okay, so and of plus sign. Therefore they are, what kind of it is? First class. But it is an even degree because higher power of x is 4. 4 is an even number and therefore even degree. So it is an example of the first class and of even degree. So what is then the first class and of odd degree? So x power 5 plus x power 4 plus x cube plus x square plus x plus 1. So they are of actually equidistant. Okay, so equal in magnitude but of not of opposite sign but of equal sign. But the highest power of x, what do you mean? 5. What is 5? 5 is an odd number. That is x power 5 plus x power 4 plus x cube plus x square plus x plus 1 equal to 0. So it is a better example, okay, so of first class and of odd degree. So what is the next thing? That saying second class and of even degree. Second class and of even degree, I already that is mentioned that what do you mean? They are actually equidistant from the start and the end, but they are of opposite sign. See the example 3x power 6, where that is 3 at the last end, but it is of opposite in magnitude, that is minus 3. Okay, see, understand? And x power 5 here minus x, minus 27x power 4 here plus 27x square. Okay, so actually they are equidistant but of equal in magnitude but or of opposite sign. So what is it? This type actually second class and of even degree. Going, what is the next thing? Second class and of odd degree. Okay, so therefore the coefficients are equidistant and are equal, the first class even before. So when you put x equal to 1 by x, all it remains the same. So it is a reciprocal equation. So understand the types of 4 the reciprocal equations. And theorem. So this theorem is very useful to solve the problems actually. So in mathematically it is a basic, okay, so of every problem. So what is theorem 1? So theorem 1, you take a reciprocal equation, f of x is a reciprocal equation of any type of degree. We have odd degree and the even degree, but it's not mentioned degree n. You take a reciprocal equation, but and of first class. Okay, so first class and of even degree, what is the example then? Previously, it is the, in the 4 type of reciprocal equation, what is then? It represents the 1.